Hello guys, welcome back to one of our final lessons of the year. Today we are going to learn about congruent triangles. So congruent triangles are two triangles that are exactly the same. And when we say exactly the same, that means all the angles are the same and all the side lengths are the same. Now proofs will revolve around congruent triangles, but any two shapes can be congruent if all angles are equal and all sides are equal. So to start off, we have, to start off, we have 5 types of congruency. We have side, side, side congruency to start. So all 3 sides, and we'll see that denoted by the tick marks, match. So this side and this side match, these 2 sides match, and these 2 sides match. So since we already know all 3 sides are the same, we are also able to conclude all 3 angles are the same. Now, the next type of congruence we're going to see is side angle side. And this says that if you know 2 sides and the angle in between them are all the same, then we have congruence. So side, the angle in the middle matches, and then the side after that angle matches. Now, here with this, one thing I'm going to say, we're never going to have angle side side similarity. That actually comes down to hypotenuse leg in only right triangles. But angle side side will not produce congruent triangles because I can manipulate the other angles too much and create another triangle that has 2 sides the same, but the angle in front of one of them be different, and the angle in front of them be different, but be 2 different triangles. So we're never going to have angle side angle, angle side angle is good. We're never going to have angle side side. You don't want to be an ass. The next type works very similar to side angle side, just works in reverse. It's angle side angle. So if I have an angle and the side in between those 2 angles congruent, that's angle side angle congruency. I can also have angle angle congruency where I have 2 angles that are congruent, and then one of the sides that's not between them is the same. Angle angle side is okay. Both of these work on the idea, if you recall, when we looked at similarity, angle angle was a big similarity we talked about. It only needed 2 pieces. Well, based off of that idea, if I had 2 of the angles, I know the third has to be the same. So as long as I have one side that match up in length, then we know we're good. The last one we're going to talk about briefly is hypotenuse leg. So if it's a right angle, and this all deals with the math involving right angles and right triangles, because right triangles are very particular. You'll learn more about that inside trigonometry. But if I know one of the legs and the hypotenuse are the same length, since it's a right triangle, what we know about trigonometry is actually this angle here and this angle here would have the same measurement, assuming that these are the same. So this is called hypotenuse leg because it only works on right triangles. The only triangles we talk about with a hypotenuse are right triangles. So we're going to do 3 proofs together right now. So let's take a look at my first picture here. First picture. Now on your notes, this looks a lot nicer. So, did I grab the right? Yes, this is the blue. That's right. Good. So we're going to start statement and reason. So right away, I'm told that these sides are congruent. And actually, this has a statement off to the side. This says given D is the midpoint of AC. So that's going to be there in my statement. D is midpoint of AC. I'm also told AB and CB are congruent. AB is congruent to CB. All this is given to me. So, here with this, since something is a midpoint, that means it cuts it in half. That actually means AD and CD are the same. So based off the fact of the midpoint D, I'm allowed to say A to D and C to D are equal in length. So statement 2, AD is congruent to CD. Yep. And I know this because I'm told it's a midpoint. It's just the definition of midpoint. So I'm utilizing that fact. So I'm just going to write definition of midpoint. Okay, now here with this, I see nothing about the angles. Because I could try if I could show angle A and C are congruent. Actually, there is a way to do that with properties of isosceles triangles. You could say, since AB is congruent to BC, we have an isosceles triangle, which means angle A and angle C are congruent. We could technically prove that, but we're not going to do it that way. I'm going to do it the easier way. So that involves more stuff. This line in the middle would be equal to itself. dB is the length of dB. That's the reflexive property. So BD is congruent to BD through the reflexive property. So, I know AB matches up with BC, CD matches up with AD, and DB matches up with itself. So, through knowing all three sides are the same, I can prove my congruence by side, side, side. So, triangle ABD is congruent to triangle CBD. And the reason we know this, side, side, side. And that's our first proof with congruence. Like I said, there were other ways to handle this. We could have used some more properties in here and gone a little bit more out on a limb. That's the thing about proofs. There's no perfect way to do that. There's no do it this way every time type way. Sometimes you might overcomplicate that, and that's okay. But here, I tried to do this in the most condensed way possible. Like I said, I could have gone the route of noticing my large triangle ABC was isosceles. So first I would have to deem it an isosceles triangle by making the statement, I know AB and BC are congruent, therefore that triangle is isosceles. Since it's an isosceles triangle, I know angles across from your congruent sides are congruent, so I would use that property to say those are congruent. So if you notice, that was 2 more steps I needed to add in on top of having one of those. So that's why I'm trying to make this the most efficient way to do it. Okay? Next proof is going to be a little bit shorter. Not as much given to us or needing to write out on the side as given. There's actually a lot of information given to us. And this is a very common setup. So this is an interesting one here. So let's see, we got, that's the one that doesn't write as right. This is the brighter one. We got a setup like this where this is A, B, this point here is E, C, and D. Now we are conveniently told CE and BE are congruent, and we're told AE and DE are congruent. So let's just start with that statement. So AE is congruent to DE. Reason given. I do have another piece of this given statement. CE is congruent to BE. All that is information that is given to me. Now I had 2 sides. If I could prove AB and CD are congruent, I could prove this by side, side, side. Unfortunately, I'm not seeing math that easily takes me there. So what I'm going to go after are these angles in between them that I just highlighted in blue. Well, I know these angles are going to work for me by the fact that they are vertical angles. So we know those are congruent. And what that will allow us to say is, hey, I got 2 sides and the angle in between them congruent, so that gives me side, angle, side congruent. So let's write the rest of that out. So I know angle AED is congruent to angle, I said A, so that's going to be DEC. I know that these are vertical angles. So remember, vertical angles are across from each other. That gives me enough to make my final statement of triangle AE. Whoop, this should say angle AEB. I wrote a D there. That should be AEB. Sorry about that. So triangle AEB is congruent to triangle DEC. My rationale here is side, angle, side congruence. So this proof was really in a tough spot. Now that I've proved this, I could prove a bunch of other facts about this. I could prove that AB and CD are indeed parallel lines if I wanted. We learned about that in IM2, because I would know the angles C and B are congruent, meaning they are alternate interior angles are incongruent. So then that would mean the lines are parallel, because with parallel, lines are parallel if and only if alternate interior angles are congruent, or if and only if corresponding angles are congruent. and so forth. But that's not what we're getting at right now. We're just looking to prove the two triangles are congruent to each other, which we have already satisfied that proof. This one just had one short, easy route to do it. But again, I must make my statement, and I must give my reason to why it's true. Now, I got one more proof. This one's going to look like it's maybe in a rhombus or a diamond or something like that. We're going to do that and see how we can utilize information about parallel sides and alternate interior angles to help us out. So, let me erase this and get the next one up. So this one will have information given to us outside of the picture. I will then mark it inside of the picture and use that as my given statement. So, my initial picture looks something like this. I am told this is B, A, C is over here, and D. Have a line that cuts across here. And I am told right away that AB is parallel to DC and BD is parallel to AC. So I'm using two arrows here for this one to indicate that just these two lines are parallel, and a single arrow on both of those to indicate that both of those are parallel. So let's write that given statement. I know AB is parallel to CD, and I know BD is parallel to AC. All of this I know because this is information that is given to me. Now that I have my given information, we're actually probably going to use the same rationale 2 times in a row, but that is okay. So I'm going to start here. Since these two lines are parallel, I know this right here and this right here are congruent. So angle ABC is congruent to angle DCB. And I know this to be true because these are alternate interior angles. Now I'm going to use very similar logic here. That was between these two lines. I'm looking at these two. I noticed that this and this follow that same alternate interior pattern. So by that logic, ACB is congruent to DBC because they are alternate interior angles as well. So angle ACB is congruent to angle DBC because again they are alternate interior angles. Now that's great, but remember, angle only works for similarity. I need to show that one side is congruent. I don't care if it's an angle off to the side or in between, because I can say angle side or angle side angle. So what I realize here is BC has to be the same as itself. This line is the same length in both triangles, so through the reflexive property, I get that in-between line equal to itself. So BC is congruent to CB by the property of being reflexive. It is equal to itself. So now by angle, side, angle, I know these two triangles are congruent. So for my last statement, I could say triangle ABC is congruent to, let's see, A lines up with D. In this triangle, B actually lines up with C and vice versa. So that is going to be by angle, side, angle. Now I know this is a lot of information to take in. I did not want to overwhelm you with the number of proofs I gave you, but you're welcome during our live sessions coming up to ask for more examples and more proofs if you do need them. So we got these quick summarization. This is what you're going to need for most of this week. All three sides are the same in both triangles. That's side, side, side congruence. If you have two sides that are the same and the angle that is between those sides is the same, then you have side angle side congruence. If you have two angles that are the same and the side in between them, that is angle side angle congruence. And finally, if you have two angles that are the same but only one side adjacent to just one of them is also the same, that is considered angle congruence. And the last one is dealing solely with right triangles. So if we have a right triangle, all we need to know is the hypotenuse and the leg are congruent. So hypotenuse leg is an appropriate one only for right triangles. If you notice, it's an angle, a side, and a side. It only works because it's a right triangle. So guys, have a good one and stay safe. Thanks for watching.